Bismillah ar-Rahman ar-Rahim. Let's look at this problem. Problem 220 in the book. Okay, so assume that the average concentration of chlorodyne, which is like a chlorinated pesticide, now it is banned in the United States. In the atmosphere above the Arctic Circle in Norway was found to be equal to 0.6 picogram per meter cube. Okay, so I'll put it like this, 0.6 picogram per meter cube. This is chlorodyne. In this measurement, approximately 90% of this compound is present in the gas phase. The remainder is absorbed to the particles. For this problem, assume that all compound occurs in the gas phase. The humidity is negligibly low, and the average barometric pressure is 1 atmosphere. Okay, calculate the partial pressure of chlorodyne. The molecular weight of chlorodyne is C10, Cl8H6, and of course you should find the molecular weight of each one of these, like carbon and chloride and H. And then you can find out the total molecular weight of chlorodyne is 409.8 gram per mole. The average air temperature through the time of measurement was -5 Celsius. Remember the equation when you convert, because in order to find the pressure, we need to find the value in the concentration of chlorodyne in ppm. We have it here in picogram per meter cube. Remember the equation? We need the value in microgram per meter cube. Okay, so let's look at this picogram. Let's convert the picogram into gram. 1 gram is 10 to the 12. And later on, let's convert the gram to microgram. 1 gram is 10 to the 6. So picogram with picogram, gram with gram, and now we'll end up with microgram per meter cube. Look at that, microgram per meter cube. Good. So this would give you 0.6, 10 to the -6 microgram per meter cube. Okay, so now we should formulate our equation. We should put here the 0.6, 10 to the -6 microgram per meter cube. We need to find out the part per million by volume. You need to multiply it by the molecular weight that we found for 0.8 gram per mole. And you need to multiply it by 1000, which is the conversion factor. And of course, you need to multiply it by 1 atmospheric. At the end, this thing is divided by R. R is constant, which is 0.08205 liter atmospheric per mole Kelvin. You can see here the atmospheric cancel with atmospheric, and you could also see that the mole with the mole, and also the temperature is here. It's 268, because you have to add 273 to this. So the temperature in Kelvin is -5 Celsius plus 273, and that will give you, if you take 3, 268 Kelvin. So we put 268 Kelvin, and now you have Kelvin cancel with Kelvin, and you will have liter, and of course gram, and then you could just try to figure out a way of canceling out the other parts. Okay, so now you could find the part per million by volume, and this is 268. So the concentration in part per million by volume try to rearrange all the numbers together. You will end with 3.2 10 to the minus 11, and that is the concentration in ppm by volume. That's for chlordine. Now let's find the partial pressure. Remember the partial pressure for chlordine, since we are assuming that everything is in the gas phase, you should find the partial pressure of chlordine, this is the only pollutant, over the total pressure of the whole thing within it. So it's 1 atmospheric. Remember when you do mass I over mass total times 10 to the 6, volume I over volume total times 10 to the 6, we'll do the same thing. Pressure of that pollutant over the total pressure, 1 atmospheric, times 10 to the 6. And of course, this is equal to the ppm by volume for the chlordine. So you can see here, once you move this to this one, you will end up that the pressure for chlordine is equal to 3.2 10 to the minus 17. And of course, the unit now is atmospheric. It's very simple and very easy to do. Thank you.